Hi guys, welcome back to my math YouTube channel. My last video was about partial fractions and how to use partial fraction decomposition method to actually integrate rational functions. Guys, there's three types. I already talked about one of the types. Today I'm going to talk about the second type. So in the second type, I'm going to write the general form and then I'm going to illustrate that by actually showing you some examples. Guys, the general form, and I'm going to call this type 2. So the general form is if we have a rational function of the form, let's say px divided by, and I have in the denominator I have something like this, ax plus b to the power n. Now we have to understand the difference between these types. Guys, in type 1 we again had a rational function, but the unique thing about that rational function was that the denominator could be written as a product of distinct linear factors. But if you look at this expression right here in the denominator is not expressed as the product of distinct linear factors. Rather, you can see that they are repeating. The same factors are repeating. So that is why I like to think of this as type 2, because it is different than the previous type. So since the denominator is different than the previous type, type 1, so the right hand side, the way we break this down is also going to be different. Guys, here I'm just going to write the general form, how we are going to break this down into different pieces. But I would like you guys to think about it and see and think and like ask yourselves why it works and why we can break it the way we are going to break it. Okay, so it is going to be equal to any constant c1 divided by one of the factors ax plus b. So we start with the linear factor and then it goes to c2 divided by ax plus b whole square, and then it keeps on increasing till the last term, which is going to be the last rational term, which is going to be cn, because there's n terms, and the last one in the denominator is going to be ax plus b raised to the power n. So you can already see the difference between this one and type 1, where we had distinct factors, or distinct linear factors for that matter, and we were able to break them as some of the rational functions, but all of them had linear factors in the denominator as well. Guys, here the first one is a linear factor, but then we have quadratic and it keeps on increasing. This should still satisfy two conditions. Guys, number one is the degree of the numerator. So again, the degree of the numerator should still be less than the degree of the denominator, and that was the same thing for our type 1. So the degree of the numerator should be less than the degree of the denominator. And let us call the denominator, I can call this q of x, okay? That is the first condition that this should satisfy. And the other one is that in this case, we don't have distinct linear roots. What we have is, we have repeated linear roots or solutions or factors here. So repeated linear factors and are like, this can be written as ax plus b times ax plus b times ax plus b, but there's n times, right? So that's why it's raised to the power n. So it has to satisfy two conditions for us to write the partial fractions in this form, or break this as a partial decomposition like you see on the right hand side. Okay, so guys, now I'm going to illustrate this or use it on some examples, and it will make more sense when we apply it to particular examples. So the first example that I'm going to show you here is, well, I think this is example 3 in this partial fractions world that we have started last time. So the example is, we want to integrate a function of this form, 5x squared plus 20x plus 6 divided by x cubed plus 2x squared plus x, of course with respect to dx. So guys, as you can already see that it is a very complicated function. Of course it's a rational function, and in the denominator is a cubic function. Upstairs we have a quadratic function, and looking at this we can see that there's no easier way or direct ways or any substitution methods that would help us to actually evaluate this integral. So if all those methods do not work, then one has to go and see if the partial fraction method works. In order for the partial fraction method to work, again, we already covered type 1, this is type 2. So let us see if it qualifies for type 1 or type 2. Again, how would we do it? it has to satisfy two conditions. Number one is, which is similar for both type 1 and type 2, is that the degree of the numerator has to be less than the degree of the denominator. Guys, we can easily verify that. The degree of the numerator here is 2, right? Because of this x squared. And the degree here is 3. So it satisfies the first condition. Now let us see if it satisfies the second condition for this one or the other one that we have covered, okay? So guys, keep in mind this is still type 2. There's type 3 as well that I'm going to show you in my next videos. But in this case, in order to see whether it is in the category of type 2 or type 1, one has to factor the denominator. That's how we'll be able to figure out, okay? So let us try to do that. We are going to take this rational function 5x squared plus 20x plus 6 divided by, and guys, let us try, I think I don't need the paper anymore. Now let us try and see if we can factor this denominator. Well, obviously we can see that the x would be the greatest common factor, right? And then inside, let us see what is left inside the parentheses. We have an x squared, then I have a 2x, and then I will have a plus 1. At least I have one of the linear factors, okay? And now let us see if we can factor this, guy. So if we try to do that, so it's 5x squared plus 20x. We just have to keep on writing that numerator. We're not doing anything with it yet. And then let us see what we can do for this. Well, guys, let us try and see if we can factor it. Well, factoring this trinomial is like finding two factors of that 1 that add up to positive 2. And in this case, we can find 1 and 1. 1 plus 1 is 2, and 1 times 1 is positive 1. So that means, what do I have? I have x plus 1 and then x plus 1. Okay, so guys, I have x as one of the factors, and then I have x plus 1 and x plus 1. So I do not have distinct factors here. Like x is different than these, but then x plus 1 repeats. So that means the linear factor x plus 1 repeats. That means we can classify this into type 2, not type 1. Because for type 1, we need to have distinct factors in the denominator. But here, x plus 1, one of the factors repeats. Although this guy does not repeat, so we're going to treat this like what we would do usually in type 1. But guys, since this repeats, so we have to deal with this using this type 2, okay? So this satisfies in a way both type 1 and type 2. So now I'm going to get rid of this general form because we need space to actually do it. And then we are going to break it down using the partial decomposition, and then we'll try to evaluate the integral, okay? So I'm trying to find some space here. Okay, I got this much. I'll probably get rid of all of this here. So guys, I think we can still do something here. We know this can be written as the decomposition as a partial fractions. So we have 3 factors in the denominator. That already tells me that we should break it down into 3 pieces. So guys, I can write this as a over x. Why a over x? Because x does not repeat. So we're going to treat it like we would do in type 1. Then guys, the second one is going to be b divided by just the linear factor x plus 1. That is what we just saw with the type 2 general form. We start with the linear factor and then plus c divided by, but with the third term, we got to have x plus 1 whole square. Guys, sometimes people also like to write this as, instead of like writing it out twice, you can think of this as x plus 1 square. So it satisfies the type 2 general form. So x, guys, with this x, because it's a distinct root, we are still going to use the type 1 where we just break it as a constant a divided by that factor. That's what we did here. But then if you forget about that x, and if you only think about x plus 1 square, this one you have to do this with using the type 2 form, right? So with that, you have to break it down as any constant b divided by the linear factor x plus 1, and then any constant c divided by x plus 1 square. So if there was a 3 here, then we would go to the fourth piece, and then we'll have the d over x plus 1 cube, and so on and so forth, okay? So this is the partial fraction decomposition for this particular rational function. And now our goal, we know, is to find the values for a, b, and c. Once we have those, we'll bring them back and then try to find the integral, okay? So guys, in order to do that, we already know, if you have watched my 2 videos on partial fraction method, you already know how we actually do that. What we try to do is we try to get rid of this term in the denominator, and then from that we can solve for a, b, and c. Guys, to get rid of this piece in the denominator, all we have to do is we have to multiply by the exact same thing. So I multiply the left hand side and the right hand side by this quantity, right? So if I multiply by this quantity, and I'm not going to actually write that step, but we can easily see that. So guys, if I multiply by this quantity, on the left hand side, upstairs I'm multiplying by this, downstairs is the same thing. What's going to happen? The quantities are going to cross out, and on the left hand side, I will simply be left with, so from here, I'm going to take it up here. So from the left hand side, I will only be left with this quantity, this quadratic function in the numerator. So it's going to be 5x squared plus 20x plus 6. And then on the right hand side, let's be careful on the right hand side. On the right hand side, there's 3 pieces. We have to multiply this guy to all the 3 individual pieces. So when I multiply this guy to the first piece, guys, there's an x downstairs and there will be an x upstairs. So the x's will cross out. I'm left with only a, and then I'll have to multiply that by x plus 1 squared. So I'm going to just write this x plus 1 squared, then plus b, and let us see what is left with b. Guys, with b there's an x plus 1. We can put it in the parentheses if you like. Now one of the x plus 1s and x plus 1 will going to cross out, and I'm only going to be left with x times x plus 1 because it's a square, so one of those will cross out. Then with the c, I think c is going to be the easiest one, because with the c, x plus 1 square and x plus 1 square is going to cross out, and I'm only going to be left with what? Just the x. That's it, guys. We got rid of the denominator. From here, now our goal is again to solve for a, b, and c. Again, there's few different ways of solving for a, b, and c. I'm going to show you my method, which kind of is easy and like a quick method. So what I like to do is, I like to think in terms of isolating variables and solving for the other one. So guys, I usually like to start from the last one, but I mean, you can start from anywhere you like. Looking at this last piece, what I'm looking at here is that it's multiplied by an x. So if I set x equal to 0, this term vanishes. Well, luckily for me, if I set x equal to 0 again here, then this term is also going to vanish, but this will stay, so I can solve for a. So I'll be able to solve for a if I set x equal to 0. Again, guys, keep in mind, you can choose any value for x, but we want to start with those values that will help us to isolate or eliminate most of the variables and solve for the other one. So first one, I'm going to let x equal to 0. So if I let x equal to 0, we got to substitute that to both sides. If I substitute on the left hand side, this becomes 0, this becomes 0. I'm only left with 6 on the left hand side. On the right hand side, I have a times 0 plus 1 is 1, 1 squared is just 1, and these terms become 0. So from here, it implies that a is positive 6. So I already have the value for my first constant a. Now let us try to find the value for the other two. So to find here, guys, I'm looking now at this term, okay? If I set x equal to -1, so what's going to happen? -1 plus 1 is 0, 0 times this b is 0, this term vanishes. Again, this term also goes away because -1 plus 1 is 0, 0 squared is 0, 0 times a is 0. But this term is going to stay, so I will be able to solve for c, right? So in the second step, let x equal to -1. If I substitute x equal to -1, I got to do that on the left hand side. Guys, when you are working with negative numbers, please be careful. I would actually write the step for that. So it is 5 times -1 squared in parentheses. If you are trying to use a calculator on that, please put that -1 in the parentheses, otherwise you will get a completely different answer, okay? And then plus 20 times -1 and plus 6, that is the left hand side. And on the right hand side, let us see what happens on the right hand side. Guys, I need more space, so I'm going to get rid of this. And then on the right hand side, guys, stay with me, -1, this goes away. This term, both these terms go away. It's only c times -1. You can just say -c, right? C times -1 is just -c. Let us simplify this further. From here implies -1 square, we have to follow the order of operations. -1 square is 1, 5 times 1 is 5, and this is 20 times -1 is -20, so it is 5 minus 20 plus 6 equals to -c. If I simplify this, it's going to be -15 plus c, which is -15 plus c is -11 equal to -c, right? I want to make sure I don't make any mistakes with that. -5 plus 6, I think it is -9, I guess, right? Sorry about that, -9. And then what is c? Guys, you just have to get rid of that negative. You can divide both sides by -1 or multiply both sides by -1. Same thing, c equals to 9. I got my c, I got my a. The only thing I need is my value for b. So let us see how we can calculate the value for b. To get b, let us see if we have any other options. Guys, if we set x equal to 0, which we did, but then b is also gone, and if I set x equal to -1, which we did in this case, it is still gone. So it seems like we cannot pick any number that so that the b will stay and the other two will go away. So if we are in that situation where we cannot do that, then in that case, guys, we have no other option but to choose any value for x. And it is just going to work out because we already have the values for a and c. Guys, think about it. There's 3 variables and 1 equation. Now we have the value for 2 of them. We only want to solve for the third one. We can pick any value for x and solve for that third one. Okay? So in order to do that, what I'm going to do is, it's up to you which values you want to choose. Of course, you cannot choose 0 and -1 because that will, like, b will just go away. So you have to choose anything different than 0 and -1. For convenience purposes, and you would agree with me, for convenience purposes, guys, I'm going to choose x equal to 1. Okay? Because if I choose x equal to 1, I am guaranteed that b is not going to go away. Well, in this case, even a and c will stay, but that is fine. We have the value for a and c, so we can simplify those pieces. But I'm guaranteed with x equal to 1, I'm guaranteed that b will stay, and we want b to stay because we are solving for b. Okay, so let us carefully substitute x equal to 1, and I'm doing it only for just convenience. Okay, it's easier to work with just x equal to 1. So when I substitute 1 here and 1 here, so what's going to happen? 5 times 1 is 5 plus 20 times 1. So let me write that. So it's 5 times 1 square plus 20 times 1 plus 6. That's on the left hand side. And let us see what happens on the right hand side. Guys, on the right hand side, I have a times this, but I already know the value for a. So I'm going to put 6 times, and then 1 plus 1 is 2 square. I can already write that. And then plus b. I do not have the value for b. That's something I have to find out. X equals to 1, so times 1. And then 1 plus 1 is 2. We can simply do that then. Plus c, we already know the value for c. I'm going to replace that c by 9. And 9 times x is 1. So it's all going to work out well. We just have to be careful and we have to do the steps. Like, we cannot rush through the steps. 1 squared is 1, so it's 5 plus 20 plus 6. And on the right hand side, let us simplify. 2 squared is 4, 6 times 4 is 24. This is 2 times 1 is 2, so I can write 2b plus 9 times 1 is 9. Let us simplify, guys. I think we need more space, but meanwhile, let us first at least simplify this. So this is going to be 25 plus 6 is 31, and then let us add these two. 24 plus 9 is going to be 33 plus 2b. From here, we can subtract 33 from both sides. Then I get 2b equals to 31 minus 33 is going to be -2. And if I divide both sides by 2, what do I have for b? b is -1. Hey, I have the value for a, b, and c. Well, it was a lot of work, but I mean, we had to do all that to find that a, b, and c. And guys, keep in mind, we don't want to do all that extra work. If we can evaluate this integral just by using any shortcut methods, any direct formulas, or substitution, or integration by parts method. Guys, those methods did not work. That is the reason why we are actually going and doing this partial fractions method, okay? So let us make some more room and then we can bring this all together. So guys, I have to get rid of all this. So we have a, b, and c. So finally, my integral is going to look like this. So it's going to look like this. So I have a times a 6 over x dx. That was my first term. Guys, I'm sorry, I have to squeeze everything in here, so I cannot like have everything what I have written. And these problems like take a lot of space. So that was the first term. Then the second was b over b is -1, and then I remember this being x plus 1. Okay, and then the last one was plus integral of c over x plus 1 whole square dx. Right? These are the 3 terms. Can we write the integrals for each? Let us try. So the one thing that I'm already going to do is this negative. I'm going to take this negative outside, so it will become negative right away. And now let us try to write the integrals for this. To write the integrals, again, I will have to make some more room. So let's see what we can do in here with these integrals. I already like the first two because they're both like the denominators are linear pieces, but the third one has a quadratic denominator. So let's see if we can handle that. I think we will be able to do that. So from here, the integral of this will be just simply 6 ln of x, right? We know the integral of an inverse function is just the natural log of x, and 6 you just take it outside. No big deal, guys. Minus. We also know how to handle these guys because they are very similar to inverse functions, but all this is here like it's in the type of ax plus b. So when you have something like this, still a linear function, what you do is you just write it as the log of the x plus 1, whatever this function is right here, as long as this is a linear function, and we divide by the coefficient of x, or I like to think in terms of like we divide by the derivative of the inner. But what is the derivative of this whole thing? It is just 1. And if you want to think in terms of the coefficient of x, well, the coefficient of x is 1 as well. So I don't even have to write that 1 in the denominator. It is understood. Now this guy right here. So this is not an inverse function. So first what we have to try and do here is, guys, let us do this on the side. So this, we cannot treat this as an inverse function because there's a square here, okay? Now let us see if there are any direct ways or shortcut methods to actually evaluate that integral. So guys, we may have to rewrite this so that we can see that it qualifies for one of the shortcut methods. So guys, this can be written as 9 times x plus 1 whole square dx. And when you look at something like this, please just connect this or relate it to something like if you have 9 over x squared. How would you integrate this guy? Well, you would bring that x squared upstairs, and if you bring that x squared upstairs, it becomes x to the power negative 2. You would do same thing for x plus 1 whole square. You bring it upstairs, sorry, it becomes, there's a negative 2. The exponent, the sign of the exponent changes, right? So from here, guys, let us remind ourselves how to do something like this. It is very similar to actually doing something with the power rule for integrals, right? It's like what you would do if you have x to the power negative 2. You would just simply use the power rule. Guys, we will still use the power rule as long as this is a linear function. All you have to do is at the end you have to divide by the coefficient of x, or you divide by the derivative of the inner. In this case, the derivative of the inner, which means the derivative of x plus 1 is just 1. Or if you want to think in terms of the coefficient of x, that is still 1. So that's not going to really make any difference here. So let us use the power rule and write the final integral. 9 just comes outside. Using the power rule, we know it's to the power n plus 1 divided by n plus 1. Negative 2 plus 1, which is negative 1 divided by negative 1. No need to really write that another 1 downstairs. So if we simplify this, you can rewrite this as, we don't like to write negatives in the denominator, so I'm going to bring it upstairs, and then usually we don't like to have negative exponents, so what I'm going to do is I'm going to again bring this back downstairs. So this is the integral of this function, so it was not too complicated. We could handle it. Guys, as long as this is of the form ax plus b, the linear form, we can handle these, okay? If it's a quadratic, then we have to probably think about other ways of doing it. So let us bring it here together, negative or minus 9 over x plus 1, and then don't forget to put a plus c. Guys, this is it. This is the integral of that rational function, which of course is not here right now, but we had to get rid of all of that so that we can finally finish this problem. But guys, I know and I understand there's a lot of steps involved, but these are the type of examples that one has to deal in calculus 2. This was type 2, partial fractions. I will see you in the next video with type 3 and some examples. Till then, guys, take care.